In this lesson, we're going to talk about the chain rule, which is exactly like the power rule, just on bigger stuff. So far, we've done the power rule just on an x or any other variable for that matter. And the big focus is you bring down the power and then -1. And today we're going to talk about what would happen if it's kind of on some bigger stuff. So jumping in, we're going to find the derivative of each of the following. The main basis of the chain rule is you still pull the power in front, just like you normally would. So 3x squared plus 2x. You would subtract 1 from the power, leaving that at 2. The extra part of the chain rule is when there's a whole extra junk in here, you also have to do the derivative of what's inside. So the derivative of just what's inside the parentheses would be 6x plus 2. And that is the extent of the chain rule. You can clean it up a little bit. I could put the 3 and the 6x plus 2 in front. We typically like to do that. Put the things with powers at the end. And I could distribute this, so I could end up with 18x plus 6, and then 3x squared plus 2x to the second. So the chain rule, not much different than the power. In fact, it's the same thing. It's the power rule just on bigger stuff. So you pull the power in front, you -1, and then you have to do the derivative of what's inside. The next one has got a cubed root, which is the same as a 1/3 power. So when I go to do the derivative, the 1/3 is going to come in front. I have to -1, and I have to do the derivative of what's inside the parentheses. So simplifying a little bit, since I have a negative exponent, I'm going to need a fraction because that's going to have to go in the denominator to make it positive. 1 is on top, 3 is on the bottom. All of this goes in the denominator. And then 6x sits on top. So the last thing you could do is kind of simplify that. End up with 2x over 3x squared plus 2 to the 2/3. Next one we'll do an e. The derivative of e to the x is just e to the x. So it'll be this whole thing. But the chain rule says that once you do that derivative, you also have to do the derivative of kind of, and here's where it gets weird. Up here it was like the derivative of what's inside. Here it's going to be the derivative of the exponent. This is technically the inside part. That's your variable. So doing the derivative of just this, the derivative of sine is cosine. And because there was something in the way inside parentheses, we also have to do the derivative of that. You kind of just keep drilling down each set of parentheses until you run out of things to take the derivative of. So we took the derivative of this. Then we took the derivative of this, then we took the derivative of that. So kind of just working your way through. 10x could come in front along with the cosine 5x squared, and then the e sign. Nothing about that changes. So again, we did the derivative of e to the x, which is just e to the x, so you copy it down. Then we had to do the derivative of the exponent. The derivative of sine is cosine, 5x squared. The angle doesn't change. Remember, this is cosine of an angle. And then we had to do the derivative of what was inside the parentheses, which is 10x. Kind of like a double chain rule on that one. The next one, we've got an ln. And anytime you do the derivative of an ln, it's just 1 over that thing. And we have to do the derivative of what's inside, which would be the parenthesis part. So looking at that, I'm going to pull the 2 in front. Doing a chain rule to the first power. And I need the derivative of what's inside. So I'm going to have 4, 2x minus 5 to the first, 2x minus 5 squared. So since they each have a 2x minus 5, I can take out one of them, and I'd be left with 4 over 2x minus 5. Two more, couple of trig examples. So I've got a cosine squared here. This is the same as writing cosine squared. And once you kind of see that power on the end, then you know to bring in the 2. This would come down to a 1 power. And then the derivative of what's inside. Then you just have to do the derivative of cosine, which is negative sine x. Not much cleaning up here. I could take the negative and the 2 out front. And that's about it. One more to go. We've got a sine function, and we're taking the derivative of that. So I just have to turn it around. Derivative of sine is cosine. And you have to do the derivative of what's inside. So the derivative of this, keep in mind that pi is just a number, so the derivative would be 2 pi x. Cleaning that up just barely, just kind of throwing some stuff in the front. And that's your derivative. So chain rule is not any different than the power rule, nothing different than what we were doing before. What you have to remember is once you pull the power in front, go up to this one, once you pull the power in front, you minus 1. You just have to do the derivative of what was inside the thing that had the power.